Completing a square is a technique that we'll use to transform a polynomial into a slightly different form. And there's two reasons why we would want to do this. Number one is it's a technique that we can solve quadratic equations that can't be solved by factoring. And also it's a way that you could put things in a different form that ultimately may lead you to be able to do a U substitution or use a generic formula for an integral or something of that sort. So I do this a little differently than the book does. And so if you've learned it the way that the book does it in your previous algebra classes or whatever, feel free to use that if that's what you know and that's what you're comfortable with. This particular method that I use, you can kind of get really, really fast with it without thinking too much about what all these factors are. And so you'll see that I use this factor capital B, and oftentimes when you're looking at the other methods, they'll use a lowercase b over 2. And so I just find that B is easier to use than starting out with something divided by 2. So what we're going to look at is we have a general polynomial, and let's say B is a constant here. So we have a quadratic polynomial that basically has two x's in it, right? We have an x squared plus some coefficient times x plus some constant. And so if it happens to be a perfect square, in other words, if we can take something, x plus something, and then square the whole thing, it expands out to this form. And so if we have something like x squared plus 6x plus 9, this directly can be factored into x plus 3 squared. Okay, we've done that before. So with this method of completing the square, the way we're going to be looking at this particular polynomial is that I'm going to look at what 2b is. And so you can read 2b right off of the equation. And so here, if b is 3, 2b is 6, b squared is 9, you can see that the b that fits in here leads to a 2b here and a b squared there. Okay, so if I take an example like this, now this one you should be able to factor pretty readily into a perfect square. But let's say you didn't know it was a perfect square. So the first thing in this method you do is you would write 2b equals 8. You read that right off of the fact that it's the coefficient in front of the linear term. So we say 2b equals 8. And so we divide both sides by 2 and we get b equals 4. And b squared equals 16. Now this all fits nicely because then we know that we can factor this to be just x plus 4 squared. Now this method is called completing the square because what we're actually going to be doing is we're going to take things that aren't perfect squares and we're going to make them be perfect squares by adding and subtracting something. So remember when we were dealing with rational expressions and we were trying to rationalize radicals out of the denominator, where sometimes we were trying to use some simplifying factor by multiplying both the numerator and the denominator by the same thing. What we're doing in essence there is multiplying anything by 1. And so it's true that we can do that with any factor. We can multiply it by 1 and still end up with the same value. Completing the square relies on a similar technique, except that we're going to be adding 0. Okay, and so the thing to remember is you can add 0 to anything and you still end up with that thing that you started with. It's the form of 0 that we're going to add that makes this thing work. So let me go to the next example to show what I'm talking about. Now x squared plus 6x factors, right? It factors into x times x plus 6. That's not what we want. We want to factor this as a perfect square. In other words, we want to complete the square. I want some instance where it's x plus something in parentheses squared, and then I may have to add a constant or something like that. I want to transform it into that form. So the thing that I'm going to do first is I'm going to say, okay, 2b equals 6. That means that b equals 3 and b squared equals 9. So now I'm going to take this 9, this b squared thing, and I'm going to add it and subtract it to my expression all at once. So I get x squared plus 6x plus 9 minus 9. And notice, now I haven't changed the value of this expression. It's exactly the same as this because all I've done is added 0. Okay? But now look at the first three terms. This x squared plus 2bx plus b squared, these first three terms factor, and you don't even have to think about how you factor them because you know that the factor that you're, or the term that you're going to have with the x is going to be this b thing. So this is going to factor like x plus 3 squared, and then we retain the 9. So what we've done with this expression, the way we describe this is that we've completed the square. So we get this form like this. Now in a couple days we're going to talk about making graphs of graphs of quadratic equations, and it turns out that putting it in this form is way easier to graph than this form. And that's because, remember when we were doing translations of functions, if we know what f at x equals x squared looks like, that we can add, you know, that h inside the squared, and we can add the k on the outside to move the vertex around. Well, this allows us to figure that out directly by doing that kind of manipulation. Okay, so I say you try on this one, but let's take this one step by step. So we have two of these. So the first one works just like the one I just did. So the first thing I want to do is I want to identify my b factors. So I say, okay, 2b equals -4, therefore b equals -2, we just divide it by 2, and then we can square that. -2 squared is 4. So then the thing I'm going to do is I'm going to take my b squared and add it and subtract it now. Okay, so I'm just adding 0. So here I add and subtract b squared. Then I'm going to take these first three terms and they factor. They factor to x minus 2 squared. I know that that's the way they factor because I've already calculated what b is. And so I get x minus 2 squared, and that's the first three factors, and then I have this, or the first three terms, then I have this fourth term which just hangs around on the outside. So I've completed that square. Okay, so that's when you're missing this, that last term. If you have a term in here, like x squared plus 2x minus 1, this doesn't factor, right? So there's no factoring, so it's not even a perfect square. But we'll do the same thing. So we'll say 2b equals 2, that means b equals 1, and b squared equals 1. So what I'm going to do is I'm going to add and subtract the b squared. So I get x squared plus 2x plus 1 minus 1, and I'm going to keep that minus 1 from up here because I don't want to change the value. So just coincidentally, what I'm adding and subtracting, I'm also subtracting because I had that in my original expression. The first three terms here now is a perfect square. And we know it's going to be x plus 1 because the b tells us what it is. And so we get x plus 1 squared, and then minus 1 is just minus 2. So we then have this expression here. Okay. Let me add one to the... Okay, so try that one by completing the square, okay? And I have two models up there that you can do. Okay. Luke, what's the first line here then?
X squared plus 8x minus 2 plus 18 minus 18.
Okay, how did you get all that?
Oh, sorry, I jumped lines. 2b equals 8.
Mm-hmm.
B equals 4. B squared equals 16.
Okay. Next thing then you said?
X squared plus 8x minus 2.
Yeah, let's keep the b squared first, okay? So we got plus 16 minus 16, and then minus 2.
Minus 2. Yep.
Okay? All right. The reason why I put it in here is because I want to keep these three together. And so how does that factor then?
becomes x plus 4 squared minus 18.
Okay, so then this factors, because we know the way it factors is b down here, and so we've taken care of this, and then we have minus 16 minus 2 simplifies to that. So if you expand this and simplify it, you'll get back to here, but this is the completed square version. Now you may wonder, where does the word completing the square comes in? Well, part of it is that, you know, we're adding something to complete this square. The other thing is, if you draw this thing geometrically, what you're going to find is that you have essentially all of these things reduce into some geometry like this, and you're finding what this little square up here is that you add. And I think your book has a discussion on that if you want to follow that line of thinking, but we won't spend too much time with that. Anyway, so there's that. Okay, so one of the things we can do with this is that we can solve by completing the square when we can't factor. So clearly we can't factor this. X squared plus 6x minus 3, if we factor it, there's no way to go, right? Because the products that make us negative 3 won't ever add up to positive 6. All right, so the first thing I do is I'm going to put my b factors in there, and then I see b squared is 9, so I'm going to add 9 and subtract 9. And then I'm going to take the first 3 terms and then simplify the negative 9 and negative 3. So you can see I have from this 3, that's how these first 3 terms factor. And then simplify to the negative 12. And now I'm going to continue to solve. Okay, we're going to do this by first isolating the square. X plus 3 squared equals 12. Take the square root of both sides, and remember it's plus or minus the square root of 12. And then we'll subtract 3 from both sides and simplify the square root of 12. 12 is 4 times 3, so we can take out the 2 squared, the 4, to get a coefficient, and there's our answer. Now there's a couple of variations on how you see completing the square. And maybe what you've learned when you're doing this is, instead of adding the 9 and subtracting the 9, the first thing you do is you bring the negative 3 over to this side, and then you add 9 to both sides of the equation. If that's the way you've learned it, that's fine. It's the same thing. The advantage of the way I'm showing you how to do it is that you can complete the square without having an equation. So if you're just trying to form an expression into something that looks like a form that you'll find in calculus, you don't need to add things to both sides. You can be working within the expression. Okay, so now here's one that I'd like you to try by solving, by completing the square. So it doesn't factor, and I'd like you to try that one. Okay, so far we're up to this point. And so then we add 65/4 to both sides, take the square root, plus or minus 65/4, and so we'll take out the square root of 4, which is just 2, and then we'll subtract 7/2 from both sides, and we get negative 7 plus or minus 65/2. Okay.